Hello, everyone, and welcome to the Newton's Second Law Lab Pre-Lab, Part 2. So this is where we are going to keep the force constant, change the mass, and measure the acceleration. Kind of the opposite lab to Part 1. We're still going to use a modified Atwood's machine, and you guys are still going to use the Pivot Interactive for this. And it's really the same setup as it was in Part 1. Right? Except we're going to change the mass and leave the force constant. So just to remember which part is which here, and if we do a little force diagram of the system, this is the same as we did in part 1, right? There's a force of gravity acting on cart A, which we'll call F of GA. There's a force of gravity acting on B, which in real life, the hanging mass, which would be down, but since we've pulled it up next to A to take advantage of the fact that it all moves together as one big thing and to get rid of the tension and the massless, frictionless pulley, right, it would act to the right in this diagram. Right? And then we'd have a normal force on the cart, right, and those would balance out because it's not accelerating vertically. Right? It is horizontally, but not vertically. No acceleration, no net force. Forces have to be balanced. So again, what is the constant, or what is the net force in this case? It's the force of gravity acting on the hanging masses, the weight of the hanging masses. And we know how to calculate that like you had to do in the first part of the lab. We take the hanging mass and we multiply it by the gravitational field strength near the surface of the Earth is 9.8 newtons per kilogram. Now in this half of the lab, we want to keep that constant. So if we don't want to change the force, we can't change the hanging mass. Right? So we're going to pick a hanging mass and stick with it throughout this entire part of the lab. Okay? If you remember in part 1, you changed the hanging mass to change the force. You kept the system mass constant. So we're going to do the opposite thing here. So you're going to go in, and of course down in the parameter selection panel at the bottom, you can choose different hanging masses and system masses. In this part of the lab, we're going to keep the hanging mass a constant 80 grams, please. 0.080 kilograms. So please choose the 80 gram one, and don't forget to hit load. Right? Each time you want to change it, you got to hit load, but make sure your hanging mass is the same every single time, and that way your slope should match what I think it should be. Right? When you go back to finish up the Pivot Interactive. This, by the way, is part 2 of the Pivot Interactive. It's called this, Acceleration versus Mass with Constant Force. So you don't have to do part 1 again. You've already done that. Now you're jumping into part 2. So in this part of the lab, you're going to change the system mass. Right? We're going to do all the different system masses that are available, but you're going to keep the hanging mass the same all the time. Okay? Again, on your lab sheet, right, it'll give you some steps on how to do that, and it'll also give you a nice data table so that you can fill in the things, right? We're going to have to calculate the acceleration, right? And we're going to do this the exact same way you did part 1. You're going to use the ruler to measure a displacement and the stopwatch to measure the time it takes to move a certain displacement. Again, we're going to use 40 centimeters or 0.40 meters. And then you'll be able to use the third kinematic equation to calculate the acceleration. Here's the third kinematic equation. Displacement is initial velocity times time plus 1/2 the acceleration times the time squared. In these, they start from rest, right? When the cord gets cut, right? That's your 0. That's when you're going to reset your stopwatch where the cord gets cut. And so that means your initial velocity times your time is 0. That drops out. So if we want to solve for the acceleration, we've got to multiply by 2 and divide by a time squared. Right? And so this is the equation you can use to calculate your acceleration. Measure the displacement with the ruler. It's actually going to be 0.40 meters every time. And measure the time with the stopwatch. Don't forget to square it. Right? That's a common error. Don't forget to square it. Right? And then calculate your accelerations. And then you'll be able to make a graph of acceleration versus system mass with constant force. Except, right, in the first lab, your graph was a nice linear graph that went through 0, 0 right away. Not going to be that way this time. You are not going to get a linear graph. In fact, you're going to get a graph that looks different than any graph we've seen so far. It's a new relationship we're going to see. You might remember that when you don't have a linear graph, you have to linearize it. Right? You have to do something usually to the horizontal variable, and I want you to work with the system mass in this case. right, by either squaring, square rooting, or inverting, which means 1 over. Right? And one of those three things will turn this into a linear graph. Follow the steps on the graphical analysis sheet. Right? It's on the back of it, the second page of it, if you will help you linearize. Right? When you're done. If you're having trouble, call me over. Right? I'm sure within a step or two I can help you decide what to try in order to linearize the graph, but follow the steps. All right? Or you can just try to guess and check your way through all three things you can do. Right? But if you think about it, you might be able to get a handle on the relationship and then, make an educated guess of which one to try. Okay? But it's not going to be linear, so you're going to have to linearize. A little more work on the graph this time. And then, as before, there's some questions about the relationship. There's making math models and defining what different things are, right? So you got to finish the lab sheet. And then we'll do the post-lab for this the next day. So be careful with this one, but enjoy part 2 of the acceleration versus mass with constant force of the Newton's second law lab.